well, good afternoon, everybody. This is our last session of the STEM Summit today, so we are so excited that you stayed and you're with us today. I'm Karen Harper. I currently work with TSIN on a project called the Reach Them All Initiative. We are really excited about rolling this out. You will start hearing more about it this month or through the summer or even in the fall as your districts start bringing this awesome training and information to you. And we'll share a little bit more about Reach Them All at the end. But I met you through Reach Them All in October.
Yes, through the Computer Science Leadership.
Yeah.
So I am Jessica Chambers. I teach 4th grade at Catlettsburg Elementary in Sevierville, Tennessee, and have had the wonderful opportunity to be part of some of the lessons for Reach Them All through computer science and some different things with TSIN. So it led me to this opportunity and sharing with you guys some of the awesome things my students do in the classroom.
All right, so when we met in the fall, she was part of a teacher team that came together to write some model lessons showing how computer science and computational thinking integrated. Here, I'm going to grab that from you real quick. Okay. And they first came together, and when we talked, I was like, well, what do you want to do? We need to show a lesson you would normally teach with your standards. We need to integrate that computer science and that computational thinking. And she's in love with this lesson. It works beautifully. It hits standards you all already teach in elementary, and we were able to pull in some incredible computer science connections. So.
And one of the great things is I teach both ELA and social studies, so this is something that goes across content areas. It is not something that is just ELA, it's not something that's just social studies, but you can also do the same things with science and math as well.
So before we get into Jessica's lesson that integrates social studies and ELA together with this research activity, I want to take a few moments first to set up computational thinking and computer science and what it is and what it isn't. So computational thinking is a strategic thought process, and a lot of times you're going to see computational thinking and computer science used unplugged. So you're not going to necessarily need a device, and you can still be doing computer science. All K-12 students can do this and can learn computational thinking. It can be integrated in all content, including PE and your related arts, and it's a great entry point for teachers, especially our elementary teachers, when learning how to integrate these concepts into their current curriculum. So I do want to stop and just take a few minutes to show you this awesome video. This is on YouTube. It's also linked. You'll have access to this presentation and her lessons and everything we share. But this is a great video to use with your teachers to kind of understand how computational thinking is integrated. And we really want to highlight 4 computational thinking practices: abstraction, algorithms, pattern recognition, and decomposition. So here we go.
How do you map the entire human DNA sequence? Is it really possible that William Shakespeare wrote all of the works that bear his name? Can you create an intelligent computer program that can write its own novel music compositions? What do these 3 real-life questions have in common? Well, answering these questions requires the use of computational thinking, which is a way of thinking that more and more people are using to solve problems each day. So whether you teach math, science, computing, or the humanities, computational thinking can be a powerful addition to your classroom activities. So what is computational thinking?
Computational thinking is an approach to problem solving. So it's taking apart a problem and figuring out how to attack it using what we know about computation. There's 4 major sort of facets of computational thinking. One is decomposition, breaking something down and figuring out what all the parts are and how you might divide up a task.
And then there's pattern recognition, which is finding similarities and differences between these parts in order to make predictions. Pattern generalization, or abstraction, which is finding the general principles that generate these patterns. And finally, there's algorithm design, which is developing the step-by-step instructions that solve similar problems. People are learning to apply computational thinking to solve problems in many disciplines. When people ask difficult questions, which are more easily solved by computers, or discover insights through analysis of large data sets, they are thinking computationally. Computational thinking is the reason we now have fields like computational biology and computational chemistry. It's also the reason we have new techniques we can use in literature, social studies, and the arts.
So when we start stepping back and looking around us, we see computational thinking everywhere, and it doesn't have to be a scary thing.
Some people confuse computational thinking and computer science, but they're quite distinct. Computer science is an academic discipline involving the study of computation and its application using computers.
Whereas computational thinking is a way we go about attacking problems.
Right, using big picture processes and abstract ways of thinking.
It's something that you could use regardless of whether or not you're a computer scientist or something else. It's a general skill that would benefit you.
Computational thinking increases students' confidence in dealing with ambiguous, complex, or open-ended problems. We believe that all students should learn computational thinking, regardless of subject or age group.
Being able to take a problem, break it down into many different sized pieces, work on each one individually, and eventually bring it all together to solve something, that's a skill that can benefit anyone.
Imagine that you're a journalist and that you want to know what people are saying about an upcoming election. One option is to ask people on the streets about their opinion. Another option is to use a computer program that can analyze social media posts on thousands of web pages in just a few seconds. See, this is an example of the benefit of approaching a problem computationally. So, in the past, if students wanted to see and understand data, they needed to collect the data manually. Now, by developing an algorithm, students benefit from quick results and are able to focus their attention on insights rather than data collection or calculation. By leveraging the strengths of technology, we can focus on our strengths as people, developing insights, analyzing situations, and drawing conclusions. We don't want students to simply use the models that we teach. We want students to be able to create their own models. And to do so, students must find the hidden patterns and insights that can be discovered with computational thinking. Computational thinking is not an additional burden or an extra topic that needs to be taught. Rather, it's an enhancement to your existing curriculum.
So with my students, early on, I just try to use everyday examples to help them understand that it's something that's accessible to them, and then they can start to see how computational thinking does exist in other aspects of their life.
If our students are technology creators, armed with computational skills, they will not only be able to participate and position themselves professionally in a global society, they'll also be able to contribute to society by solving big problems using creativity. So how did we map the human genome? Well, algorithms and computer programs helped us to sequence the millions of base pairs in our DNA. And what about Shakespeare? Turns out computational analyses of the vocabulary, themes, and styles in Shakespeare's works confirm that he could have indeed written all of the works attributed to him. And that intelligent music-composing computer program? Well, computational thinking was used to find patterns in existing musical compositions and write programs that produced brand new compositions based on those patterns. All of the remaining grand global challenges facing us as humans are problems that require an interdisciplinary approach. By integrating computational thinking skills in all of our subjects, we're preparing students to contribute new solutions to seemingly impossible problems. So yes, many mysteries still remain. For example, what causes gravity? Can we create cures for diseases like cancer? We may not be able to answer these questions today, but perhaps with computational thinking skills, our students will be able to answer these questions in the future.
All right, so that was a great way to break these down. So TSIN and the Reach Them All program focus on these top 4. These aren't the only ways you can bring in computational thinking, but these are the ones we are focusing on in this first year. So algorithms, step-by-step instructions, pattern recognition, decomposition, and abstraction. And then Jessica's lesson is going to really focus here today on showing you how to use abstraction. Because when our students do research, we do research in every content. We research artists, we research social studies figures, which is what she'll show you today. But there's a lot of information out there when you research, and to help students really focus on those important details, there's some things you can put in place. And so this is a great place, a great example of abstraction. And it's hard to find examples of abstraction. Abstraction to me is one of the hardest computational thinking practices up there to bring in. But you can do it through research and through focusing on important information. So this is a great little video that is perfect for kids. It would be great in elementary. We're going to show it to you. Really kind of breaks down what abstraction is, and since that's the strategy she's using in her lessons, we want to go ahead and show this to you, and you use this with your students.
Abstraction is a problem-solving tool that helps you to simplify a situation by removing unimportant information and focusing on what is truly important in a given situation. Suppose you want to find the best bus route between 2 points in a city. There is a lot of information to sort through. However, not all of it is important for this task. For instance, the location of tourist attractions is not important for plotting a route. So when building your abstraction, you might choose to ignore that information. Highways and streets that buses do not travel along are also not helpful, since our goal is to find a bus route. So you might choose to exclude those. Names of neighborhoods are also not important for this task as well. In the end, as the abstraction designer, you might decide that the most important information is simply where to get on the bus, which bus to get on, where to get off the bus, what times to get on and off, and the general shape of the route within the city. These pieces of information, bus number, start, stop times, and route, are essential to the task and are included in the abstraction. Note that even though it features only 5 pieces of information, those 5 pieces can represent many different routes, because every one of them has a start, end, route, bus number, and times. Because abstractions focus on the key pieces of information, they are doubly useful. A single abstraction can represent a whole class of similar things, and they make it easier to understand each one, because there is not extra information present. Every abstraction is built with a purpose in mind. For example, here are 4 different maps, visual abstractions of a city. This map is useful for finding city neighborhoods. This map is useful for finding city streets. This one shows the public transportation of the city, and this one helps them find major attractions in the city. All of these maps show the same city, but each map uses the concept of abstraction to remove what is unimportant and focus on what is important to the user. Abstraction is the process of creating an easier to understand version of a complex system by focusing only on key information.
All right, so abstraction. We're going to go ahead and pass the mic, but not really because you have your own mic. We're going to go ahead and pass the mic here and let Jessica share a little bit about her lesson and how it integrates these computer science and computational thinking strategies. And I know we have the chat box open for the folks online watching, and so if you have any questions as we go, please make sure, and we are monitoring that chat. We will also put the link when you get to the lessons in the chat for those folks, and take it away.
All right, so as I told you guys, I teach both ELA and social studies, and in thinking about this project and when I got with Karen, she wanted something that could kind of cross multiple areas. So when you look at this, primary and secondary sources is a huge part of 4th grade social studies. As we travel from the 13 colonies to Reconstruction, they have to look at a lot of documents and information and have to sort those things out. And then in ELA, both areas really, we look at historical figures. Our reading series has an entire unit on inventors and exploring those inventors, whereas in my social studies in our social studies standards, we have to look at those figures as well. Presidents, important women in history, important inventors, those both kind of collide in those content areas. And then the graphic organizer that I'm going to share with you today is one that I taught 2nd grade for a really long time. And if I'm honest, it just came with me from 2nd grade because my 4th grade babies are just as successful, and it allows them to pull out the unnecessary things and just look at those facts in a very clear format. So here is the graphic organizer, and we do have a copy of that for you today. And with abstraction, like it said in the video, it's about pulling out the things that are not important and kind of putting those away, and then pulling out exactly what you want to put that information in a usable format for students. So this graphic organizer just has 4 questions: date and place of birth, family information, facts and contributions, and obstacles they overcame. And we talk about each of these and how it applies to the person that we're researching, but we also talk about why this is important if you're going to turn this into a research paper, and we'll talk about that here in a second. And they take all of this information and they create an infographic, and this is an example of a student's from 2 years ago. And what I do is I show them how to customize a Google slide and make it look like a poster. And I explain to them, you're going to take your 4 questions from your graphic organizer and you're going to turn it into a poster. You want it to be something that is visually appealing. I always tell them, think about a poster you'd hang up in your room. You don't want it to all be one color with, a white blob in the middle. You want to make it interesting. And so they take that graphic organizer and they create this infographic and share the information with others. At some of the tables, you'll see there's QR codes, and this is what I send home. So this is their infographic and their research paper, and they send me the 2 QR codes, and this way they can take it home and share this information with their parents as well. So we're going to go through the lesson that we wrote together to display this project. I was supposed to print it off. This is why you don't print things off on a Friday in May. I printed off the wrong thing, but we're going to go through this together. So Jamie, if you'll pull that up for me. Yeah, it's not.
We'll get you that QR code at the end, don't worry.
Okay, so when you look at this lesson, you obviously see the standards as well as the important historical figures. But I want you guys to just kind of look at some of the names and things as we scroll through it and think of some things that may pop up, how you could use this in your classroom. So just glance over this for a second. And as you can see from this first page, there's a ton of individuals that your students could study, everywhere from presidents to Harriet Tubman, famous speakers, and then we go into kind of the vocabulary, once again, those computer science concepts, and talking about abstraction, and that goes into the targets, allowing them to search those websites. You give them things like Kittle or Pebble Go, somewhere where they can find that information so that they can be successful in this task. And then I said a second ago about primary and secondary source, allowing them to find those sources and use both things that they've learned in social studies and content areas and apply it to ELA. And then you've got, I'll explain the Who Was series here in just a second. And obviously, as you go through this lesson, when you guys see some of the things that they've done, it seems like a lot, but allowing them to do the work on their own time, allowing them to read the books and some different things, it gives you the ability to have it done in a reasonable time frame as opposed to an incredibly long, drawn-out class project. And the enrichment's what's on the table. We'll talk about that in a second. And then we'll go back to the other presentation. Okay, so as you guys can see in the handout that Karen is handing to you, this is a social studies 4th grade lesson. And the targets, wanting them to know keywords, wanting them to understand abstraction. The important part of understanding abstraction with this is they can get caught up in learning about the person, and they can tell you everything under the sun. I know that Teddy Roosevelt rode a horse backwards. I know that Jimmy Carter shot his sister in the butt with a BB gun. None of that is relevant to the task at hand. And so it's really just about letting them be interested, letting them learn, but also teaching them, okay, I love that you read the book and you did a wonderful job, but we're gonna pull out those 4 important facts and we're gonna look at just what is vital to the information on that person. So that's where the graphic organizer and getting them just to focus on their research and using those concepts to create a quality document on their person. So making the connections, like I said, with social studies, primary source, secondary source, and then those infographics. With social studies, sometimes the things that we put before them are hard for them to understand. They can't read cursive, so when they read those documents and some things, it can confuse them. So this is a time where we can talk about the differences in documents, and it helps them with computational thinking. So obviously, like I said, an example of a primary source, Declaration of Independence. And then secondary source, these are actually the books that I use for this project because I learned a long time ago it's a lot easier if you give them a little bit of a parameter with this. And what I do is I tell them, you can do anybody you want. It has to be a who was book. And I often get asked, well, how do you monitor if they read it? Honestly, I don't. Because it is their person, they picked it. We had a student last year that he came up to me, he was very excited, and he said, I'm gonna read about Bob Marley. And I was like, I never saw that coming, okay. So it's somebody they're interested in, and it allows them to research that person, and I don't have to monitor whether or not they read the book because they're in love with the project. And then obviously the infographic, this is one of the ones I show in the class. I used to make one on the rock, but he now has his own Who Was book, and then they would just copy mine. So I now show them this one about Albert Einstein, but it gives them elements to see, make it visually appealing, but also once we talk about taking that graphic organizer and making it into an infographic, they can kind of see how the layout makes it more entertaining for others to look at. So with abstraction, it is focusing on the main idea. As an ELA teacher at heart, we're always teaching main idea. So abstraction goes straight to that because it allows them to take what is needed and create something that is usable in the classroom, take that graphic organizer and turn it into a research paper so they can use the related and useful details, but also taking away, not that we don't want them to learn the other things, but taking what's important, and then they can share those interesting facts as they present with their classmates. We already watched that. Okay, so I want you guys to talk for a second. Talk to me. What do you think are some examples of abstraction that can be used to make a problem easier to solve? So what is something with abstraction that you could use to make a problem easier to solve? Mm-hmm.
But one way you could visualize the abstraction is if you could take out those dots for the kids, that they could see that number come to life. That might be a good visual way for the kids to understand that.
So it's almost like the maps on the screen. I like that. That's awesome. Anybody else?
When you look at contextual or
Yes, and I love one of our third grade math teachers does that wonderfully with different shapes. So that's awesome. Anybody else? And that's a great critical thinking skill to be able to say, okay, I need 12 jelly beans. Like, yes, we all want it to be pretty when you put it out in the hallway, but does it accomplish the goal at hand? Anybody else? Okay, so in conducting research, like I said, they learned so much. My son did the book on Dolly Parton, and he told me all about her toes being sewn back on. So they really do take this opportunity to learn about these people because it's somebody they're interested in. So, but it's a lot. You've got to think about 10-year-olds and some of the things that, you know, they hold on to. We want them to take research and abstraction and put those critical details in the correct place. So that's where we go back to the graphic organizer, go back to those 4 questions, and allow them just to reduce it so that it is factual and it allows them to share their learning in a clear format. So there's the graphic organizer again. Okay, so if we'll go back to the other presentation. So one of the things, if you look at the tables, you're going to see the pop bottle people. This is actually the enrichment portion of my lesson. So this doesn't go with the research paper or the infographic, and this is something they do at home. And when I copied it, I also copied the parent letter on the back for you guys, just so you could see an example. So with this, I send it home to the parents, and they take a 2-liter bottle and they turn it into the person. And I told you guys a second ago that I put these QR codes out on the table, and it allows their parents to scan it and see their work. But I'm gonna be honest with y'all for a second. I tried to give this project up 2 years ago. Okay, I was done. We were researching the famous people, and I could do that without the 2-liter bottles. And here came a first grade classroom. And they come running down the hall, and I was like, what are y'all doing? And they said, we're coming to see your people. They're still out. I said, what are y'all talking about? They said, no, we love it. Miss Jones said we could come down today. And they literally went down the line, kid by kid. And then one of the administrators walked up to me, and she was like, hey, I saw them all at car riders today. Are you going to put them all in the hallway? So seeing the excitement that this generates in my building, but also seeing how those QR codes and my students learning from abstraction, from the infographic, from the research paper, allowing them to kind of show off was an experience that I couldn't give up. So here I am still doing this project. So we want you guys to think, how did the integration of computational thinking practice enhance the learning of the content standard, and how can you integrate abstraction into other content standards? So you guys saw the great big list of standards with all the people. When I say that 4th grade social studies covers, yes ma'am, okay. So 4th grade social studies standards covers a lot of people. We also have CKLA, and I have an entire unit dedicated to about 12 inventors. So over the course of 4th grade, we study probably about 50 people, and this is how I choose to enhance that and how I choose to integrate those content standards. So what is something you could do that would computational practice to enhance those, and how could you integrate it? Yes.
So all you need to do is scan this QR code.
Oh, yeah, sorry. Scan the QR code. This is a Mentimeter, and then it'll give you an opportunity to answer the questions, and then it'll pop up on the screen.
So Jamie, just hold this for a minute and let everyone
Yeah.
scan.
So just scan it with your phone. And
This
then,
is an audience interaction activity using something called Menti. And Mentimeter is free. You get up to 3 questions on your slides to use with your audience. So once you scan it, it's going to bring you to that first question. Even those of you at home watching online can scan and participate. We're going to give you just a second before Jamie switches it to the Menti screen so we can see your feedback. But the first question is, how did the integration of a computational thinking practice, which we used abstraction, how did the integration of abstraction enhance the learning of this standard? Okay, Jamie, switch. So I'm going to see your responses start coming in, and we'll take a peek at those. I think if you hit enter, it might let the responses start filing in. There we go. So how does integrating abstraction here enhance the learning of this content standard? Okay, about 30 more seconds, and then Jessica, you want to take this slide, and I'll do the next one?
okay. Oh, okay.
Jamie's got control on it right
Okay. So what I love about seeing this is it really is about focusing on their learning. It's about giving them those facts and those details and honing that in, and I think that goes straight to the heart of abstraction, but allowing them to focus on what is important and what is relevant to the topic at hand. I love that it helps kids focus on what's important, and that they get to learn about somebody they're interested in. But it all goes back to focus and kids. Obviously, when you're working with 10-year-olds and allowing them to write a research paper, we want them to realize that what they're looking at is important.
All right, we're going to click here for our next slide. And what this is going to do is take you to the next question that we'd love your feedback on. How can you integrate abstraction into other content areas? So we do research in every grade and every content, and you can use, obviously, you probably have in mind a graphic organizer you've used with your students to organize their information, right? And so we can automatically see that in other places. I love word problems, because word problems can be in a paragraph, right, where there's a lot of information that they don't need. And so to know, we train our students in math to pull out the things they need out of those word problems. We teach them coding and skills to color and highlight and underline, and not just in word problems for math, but we even heard in ELA when you're, basically deconstructing a paragraph, right? So breaking out important moments, diagramming sentences, contextual problems in math, focusing on the main thing, main idea. So this is cross-curricular. Can anybody think of an example in related arts, such as music or art or PE, where abstraction could be used? What about a band where you have all kinds of different instruments, right? And they maybe just break the brass down and have them work together, and the woods work together, right? We could break down music maybe in that way. Okay, Miss Jamie, I think we'll go back to the main slides, but thank you for your participation with that. And that is, again, that's on mentimeter.com. All right, and so what we're going to do is go back here for just a minute. We've put this in the chat online, but this is how to access Jessica's lesson and her PowerPoint and her resources. If you want to take a picture of that so you have the bit.ly later, or if you want to scan that QR code, we'll leave this slide up for just a second before we close out today, making sure everybody has this. It also has this slide deck you're currently viewing in there as well. I know you can get it through the conference app, but we'll put that in the box file too. This slide deck, it's embedded in this slide deck, and this slide deck is inside this link. Hey, Jamie, will you do me a favor? Can you go back to that tab that has the box files, and let me make sure that this slide deck is in there? And if not, it will be just about 10 minutes after this. I'll go drop it in there. So it looks like you've got the lesson plan first, then Jessica's PowerPoint presentation, her letter to the parents for the pop bottle, the infographic poster example. This is the graphic organizer, and so give me just a few minutes. I'll drop in this PowerPoint. That way, on the conference app, if you have trouble finding this PowerPoint, we'll just drop it in box. So just make sure we're good to go back, Jamie. Just make sure we have that QR code and that bit.ly, and you'll give me a minute, we'll have it in there. But that video is a 5-minute video that we use through all the Reach Them All trainings, and it's on computational thinking on YouTube, and it's phenomenal because it really does spell out those 4 computational thinking practices we're focusing on. All right, and so Reach Them All is a train the trainer model that is about it's professional learning, and it demonstrates how computer science and computational thinking can integrate into K-12, and that's how Jessica and I first met. She joined that team, and she wrote this lesson for Reach Them All. And so each of your school districts has a Reach Them All district delegate and a team of ambassadors, and they're going to begin redelivering this information and sharing model lessons just like the one she showed you beginning this month, and many of our school districts are going to start with their redeliveries when you come back to school in the fall. If you'd like more information, this is the TSIN Computer Science Tennessee website, and you can click on Reach Them All to learn who your district delegate is and find out more about when those redeliveries are coming to you. And this is Jessica's information if you'd like to reach out to her. Did you want to add anything before we close? And then we'll be available if you have any questions afterwards.
I was going to say, we're available for any questions. If you guys have any questions about the content or how we do this with students, we will be more than happy to answer those.